Hello everyone, I'm Mamu Minokamo. Nice to meet you. In this video, I'll demonstrate the relationship between CUDA and WSL, how to set up a virtual environment in VS Code, and walk through the complete process of creating videos using FramePack. This video generation AI is designed to run with relatively little memory. Today, we'll be installing it on WSL on Windows, but of course you can also install it directly on a real Linux environment or try it in a Windows Python environment. However, for beginners, diving straight into Linux might be a bit challenging. So in this video, I'll be using WSL, which also serves as good practice. WSL occupies that middle ground, with its appeal being the balance between convenience and Linux compatibility. Now then, let's get started.
Yahoo! Today we're covering video generation AI. I'm excited to learn along with everyone.
Oh, hello Gero-san. Let's learn together. We'll be following this official GitHub page.
I think I'll join in too. Looking at the page right away, it seems we need CUDA 12.6. But I'm a bit concerned whether it will actually work properly in my environment. My machine is a bit old. Well, it seems worth trying.
Oh, hello Oyaji. That's right. That's why I'm checking the CUDA version on Windows itself right now.
Oh, Oyaji, hello. It's been a while. Looking at the results now, the CUDA version on Windows itself is 12.8. But you can't use this command unless you've installed the CUDA Toolkit, right?
That's right. The video generation AI won't work unless you have CUDA drivers installed on Windows. To be precise, having NVIDIA drivers with CUDA support is enough, and you don't need the full toolkit. Conversely, you need to keep the drivers updated to avoid errors. By the way, I didn't know Gero-san and Oyaji were acquainted.
Huh? We just met today. Anyway, the combination of WSL and VS Code is really convenient, isn't it?
Exactly, especially being able to visually confirm the directory hierarchy is great. You know your stuff, Izumi.
Isn't it a bit strange that you're meeting for the first time? Oh well, let me explain with a diagram how convenient this combination is. What Oyaji mentioned is useful, but what I find convenient is being able to transfer files between Windows and WSL with an Explorer-like interface. Additionally, the editor features are extremely useful. You can make it even more convenient with extensions. Sorry for the wait. This screen shows us checking the CUDA version on WSL through VS Code.
Even if you've installed the CUDA Toolkit on Windows, NVCC shouldn't work on WSL2. Did you install it? And furthermore, the version is different from Windows itself.
Oops, I just used it without thinking, but I believe I installed it before. We might need to check the GitHub startup script here. The reason is that the toolkit might not be necessary in WSL. In fact, in recent WSL environments, as long as NVIDIA drivers are on the host side, CUDA can be accessed directly from Python libraries. So, NVCC not working doesn't necessarily mean it won't run. This might be a confusing point for beginners.
Seriously? I wouldn't understand anything by looking at the program anyway.
Izumi, this is the perfect time to get help from generative AI.
As expected of Oyaji. That's a brilliant idea.
But don't you think? If you don't understand the basics, you won't even know what questions to ask. Besides, even if you rely on AI, you still need the minimum environment set up to run it. So, let's first make sure the installation process doesn't fail. This video generation AI we're working with uses pre-built PyTorch binaries, so you don't have to install the CUDA Toolkit yourself beforehand. That's because the PyTorch package itself includes the necessary runtime, which it uses directly. In other words, it works, even though I didn't install the CUDA Toolkit. phenomenon is precisely due to this specification. Many people might be confused by this if they don't know about it.
I see, so for this GitHub project, we don't need to install the toolkit on WSL. I've been confused with this toolkit term coming up repeatedly, but to clarify, we need CUDA drivers on Windows, nothing special for WSL, and we just follow the GitHub instructions as they are, right?
If you end up working on more advanced projects in the future, remember this toolkit. Now, let's finally copy the GitHub project files to your computer. Now, let's make it visually clear what files we have here. How does it look? It matches the GitHub contents, right? There's one more important thing we need to note. Looking at the GitHub page, it recommends Python version 3.10. When we check, this computer has version 3.12, which is different, so if we proceed as is, we'll likely get errors. So, we'll switch Python versions, as we usually do. Please refer to my previous videos for this process. If you don't like this method, you can uninstall the current Python version and directly install the recommended version instead.
I forgot to ask, but how much GPU memory does this computer have?
Oh, I should mention this so viewers can use it as a reference. The machine I'm using has an NVIDIA GPU with 8 GB of VRAM. It's a decent spec that's perfectly capable of handling video generation. However, keep in mind that generation time and image quality can vary significantly depending on the amount of RAM you have. Now then, let's create a virtual environment and begin the installation. The reason we create a virtual environment is to keep our computer from getting messy. Using VS Code, you can create a Python virtual environment like this without having to use commands.
We covered this in the previous video. You're already putting it to use.
Another feature is that the virtual folder gets created with a name .venv. Since it's created automatically, you don't have to worry about typos, which is really helpful for beginners. Being able to proceed with just clicks instead of remembering commands is what makes VS Code so great.
We name the virtual environment folder .venv so that VS Code recognizes it and makes it immediately available as a Python execution environment. It's convenient because you can use it right away without changing any settings, making development much smoother. See, when we activate the virtual environment, we get the target Python version. Now all we need to do is copy and paste the GitHub commands. If it displays like this with no errors all the way through, we're good to go. Next, we'll install the packages required for this video generation AI. The order of these commands is important, so please be careful. If there are no errors through to the end, we're good to go.
In many projects, you'll see torch written in the requirements.txt file, but often, those specifications are set to install torch from the standard pip repository.
That's exactly right. When that happens, you might end up installing the version without CUDA, in other words, the CPU version of PyTorch. Now, I've run the startup script, but I wonder if it'll work. I'm a bit concerned that it says xformers, flash atn, and sageaten are not installed.
Wow, that's a massive file size. Maybe we should explain that.
Ah, that thing? Got it. By that thing, I mean the following. Let's say you've had to redo installations multiple times because of failures, or you've deleted files because you no longer need them. But even after deleting them, your storage capacity remains the same, and your free space doesn't increase at all.
No way. Is there any solution? Wait, are you saying that even though it looks like you've properly deleted things, the space is still being used behind the scenes? Then I bet there are quite a few people struggling with free space not increasing no matter how much they clean up, right?
This is actually a feature of WSL's virtual hard disk. Even when you delete files, the size of the virtual disk itself doesn't automatically shrink. I covered this issue in a previous video where I introduced a script that automates the somewhat complicated procedure.
Seriously? That's so helpful. So I've been frequently swapping stable diffusion models in WSL. Will this solve that issue?
Whoa, this is serious. To cut to the chase, I think you'll be able to reclaim a substantial amount of free space. Great, it looks like it's ready to launch in the browser. Now, shall we test if it works?
This is amazing. It's actually running in the browser. So you can really create videos from here. I'm getting excited now. Could you make a video for us?
Sure thing. Let's prepare a single image and add some prompts. The prompt will make facial expressions change, add drone movement, and have the forest trees sway slightly. I've set the playback time to 20 seconds. There are several settings available, but I've left the other settings at their default values. FramePack is designed to be very lightweight, so it can run even on GPUs with around 8 GB of memory.
However, having more memory will certainly improve both the speed and stability of video generation significantly.
Yeah, I've experienced that before when I tried another AI tool. It stopped midway due to insufficient memory. I almost cried because it was so close to being finished. For peace of mind when running these tools, having some extra headroom is definitely better.
That's exactly right. More is always better in this case. I think you've now seen what the browser interface looks like. I'll show you a log that illustrates what Oyaji just mentioned about why having more memory is better. When we zoom in on the log, you can see how frequently it's having to offload and reload models to conserve memory. This is exactly what causes the process to take longer.
This has been really educational. When things are working successfully, we tend not to look at the logs.
Logs might seem boring at first glance, but they actually contain lots of hidden clues for early problem detection and troubleshooting. Now, my computer only has an 8 GB GPU, but please take a look at this reference table. So even with 8 GB, a 20-second video takes quite a long time to generate.
What? We have to wait that long? Even though it looks like it's creating things quickly, it's actually working pretty hard behind the scenes. It's interesting to see this kind of behind-the-scenes effort from AI. I'd like to take a closer look at that table later too.
And now, here's the main event.
What? Seriously? Is there more to explain?
Recently, I've noticed some outdated information and potentially misleading content circulating. Based on actual verification, as of 2025, I'll be introducing information that's as accurate as possible.
Perhaps because technology is evolving so quickly, there's a possibility that misinformation will naturally be weeded out in the future.
That's why I try to keep my videos as practical as possible and avoid making videos that are just explanations. Here's the actual screen I was finally able to create. At first, I thought it was generating each second separately and then connecting them afterward, but that wasn't the case. FramePack actually creates a short video first, then progressively adds the next scenes to it. This system allows for smooth creation of longer videos, even with limited memory, though it might take more time. This is actually quite a moving moment to watch. So with that, I'd like to conclude for today. Everyone, let's meet again next time. Goodbye.